Hey there guys, in this video we're going through AQA's June 2018 Higher Maths Paper 1, which is non-calculator. Let's do this. Okay, question 1 wants us to work out the cube root of 64 times 1000. Now, this isn't a surd exactly, but the rules are the same because we've got a power. So the cube root of 64 times 1000 can be written as the cube root of 64 times the cube root of 1000. Now the cube root of 64 is 4 and the cube root of 1000 is 10. So we got 4 times 10, so we get 40. Okay, question 2. The vector -2, 3 translates A to B. We want to circle the vector that translates B to A. So this vector -2, 3 is moving us 2 places left and 3 places up. So we need to do the exact opposite of that to get back from B to A. So we need to go 2 places right and 3 places down. So that vector is going to be 2 minus 3. Okay, then question 3 says circle the expression which is equivalent to 3a minus a times 4a add 2a. So don't run into this, don't forget big maths. Multiplication comes first. So this is 3a minus 4a squared add 2a, and then we can combine the a terms and we get 5a minus 4a squared. So that's our guy. Okay, question 4 wants us to circle the value closest to 9.8 divided by 0.0195. So we don't have a calculator, these numbers are ridiculous, we're going to use estimation. So we can say this is roughly 10 divided by 0.02. Now, dividing by 0.02 isn't the nicest, so what we can do is multiply the top and bottom by 100, and then that's going to give us 1000 divided by 2. So that gives us an answer of 500. So it's roughly equal to 500. That's our guy. Question 5 wants us to solve 5 lots of x plus 3 is less than 60. So we could expand the bracket, or we could divide that 5 away straight away because it's multiplying the bracket. So that's what I'm going to do. We're going to divide both sides by 5, so we get x plus 3 is less than 12, so take away the 3, and we get x is less than 9. Okay, question 6. Now this is one that's caused problems with my minions, so I'll try and explain it clearly. The height of Zach is 1.86 metres. The height of Fred is 1.6 metres. We want to write the height of Zach as a fraction of the height of Fred, giving our answer in its simplest form. So, a little aside, first of all, if we wanted 3 as a fraction of 7, it would be 3 out of 7. If we wanted 7 as a fraction of 3, that would be 7 over 3, 7 thirds. So, here we want the height of Zach as a fraction of the height of Fred. So, that means we want Zach over Fred. So, that's 1.86 metres over 1.6. Now I'm going to put that as 1.60. Now, one thing we absolutely do not want in fractions are decimals. So I'm going to multiply the top and bottom by 100. And that's going to give us 186 over 160. Now that is a perfectly fine fraction, but it's not in its simplest form as they want it. So this has at least a common factor of 2. So I'm going to divide the top and bottom by 2. So I'm going to get 93 on top and then 80 on the bottom. There are no common factors between 93 and 80, so jobs are good. Okay, question 7. Point A, 0, 2 and point B, 6, 5 are points on the straight line ABCD. We're told that the length AB is equal to the length BC, which is equal to the length CD, and we want to work out the coordinates of point D. So, we know this length is equal to this length, which is equal to this length. So, in other words, we know to get from B to C, we go exactly the same distance and route, if you like, that we go from A to B. So, to get from A to B, well, to get from 0 to 6, we go 6 along, and to get from 2 up to 5, we go up by 3. So, to get from B to C, we do exactly the same thing. So we go 6 along, and then we go 3 up. So the coordinates of point C are going to be 12, and the y coordinate is 5 plus 3, which is 8. So then to get from C to D, we do exactly the same again. So we go 6 along and 3 up. So 12 add 6 is 18. 8 add 3 is 11. So D has coordinates 18, 11. Okay, question 8. A coin is thrown 50 times. It lands on heads 31 times. Part A wants us to write down the relative frequency of getting a heads. So relative frequency means the number of times a certain thing happens out of the total number of times you do the thing. So here we're interested in heads. There were 31 heads. The coin was thrown 50 times. So it's 31 out of 50. Okay, then part B. Raj says that the coin is biased towards heads. We want to give a reason why he might be correct. So, roughly with coins, you expect heads and tails to be 50-50. So we could say anything along the lines of there were a lot more heads than there were tails, or we expected to get around 25 heads, 25 tails, anything like that. So here I'm going to say we could say 31 is 6 more than 25. I'm going to say that there were a lot more heads than tails. Cool. Question 9. The range of a set of numbers is 15 and 1/4. The smallest number is -2 and 7/8. We want to work out the largest number. So, range is the biggest number minus the smallest number. Here, we want to work out what the biggest number is. So if we rearrange this formula to make B the subject, we get the range plus the smallest is equal to the biggest. So we then want to do 15 and 1/4 add minus 2 and 7/8. So when plus and minus meet like that, the minus wins. So this is 15 and 1/4 minus 2 and 7/8. Okay, so what we're going to do here is turn each of these mixed numbers into an improper fraction. So 15 and 1/4 is 4 times 15 plus 1 quarters, so that is 61 quarters. 2 and 7/8 is 8 times 2 add 7 all over 8, so that's 23/8. Okay, So now we're trying to work out 61 quarters and then minus 23 eighths. Now, the easiest way to do this would be to go for common denominators. So we can turn 4 into 8 by multiplying by 2. So we got to do that to the top as well. So 61 quarters is 122 eighths. So we got that minus 23 eighths. And that is going to give us 99 eighths. Good times. Question 10. Y is inversely proportional to x, and we want to complete this table of values. So I'm going to put a link down below in the description to my playlist on proportion for anyone that's unsure. So if y is inversely proportional to x, that means the first thing really that we should write is y is proportional to 1 over x. So that's the proportion. The formula that we would want to use is y is equal to k over x. So our first mission is to find the value of k. Now we're going to do that by using the middle row of the table. So the middle row tells us that when x is 6, y is equal to 4. So when x is 6, y is equal to 4. So if we substitute those values in to y equals k over x, then we're going to get 4 is equal to k over 6. So if we multiply by 6, k is equal to 24. So now we know the exact equation or formula that links y and x. We know that y is 24 divided by x. So now we're going to use this guy. So when x is 12, y is 24 divided by 12, which is 2. And then on the flip side, when y is equal to 8, well, that's really then asking 24 divided by what number is equal to 8? It's 3. So if we check that, when x is 3, we get y is 24 divided by 3, which does indeed give us 8. Good time. Okay, question 11. So a large rectangle is made by joining 3 identical small rectangles. So we got this shown in the picture. We are told the perimeter of one small rectangle is 15 centimeters. We want to work out the perimeter of this large rectangle. So let's play around with just one small rectangle. So I'm going to call the small length W for width, and the long we're going to call L for length. So we know that 2 lots of the length add 2 lots of the width is equal to 15. Now, what we can spot from the large rectangle is that a length is 2 lots of the width. So we know that one length is 2 lots of the width. So what we're going to do, we're going to substitute this into the equation for the perimeter of one small rectangle. So 2 lengths is 2 times 2 widths. So we get 4 widths, add 2 widths is equal to 15. Now that tells us then 6 widths is equal to 15. So 1 width is 15 divided by 6, which is 2.5 centimeters. So now we know the length of or we know the size of the width, we can also now work out the length. So remember, a length is 2 times the width. So L is 2 times 2.5, which is equal to 5 centimeters. So now we know the measurements of the length and the width. We can go around this whole rectangle, clear them up a little bit. So I'm just going to write on the measurements that we know. This is 5, this over here is 5. The top and bottom lengths are going to be 5 add 2.5. So we're going to have 7.5 down here, 7.5 up here. So the perimeter that we want is 2 times 5 add 2 times 7.5, which is going to give us 25. So the answer is 25 centimeters. Okay, question 12. We want to put these 4 numbers in order of size from smallest to largest. So 3 of them are in the standard form. Really what we're going to want to do here is convert everything into the same form. So I'm going to write everything as a decimal. So 8 times 10 to the minus 4 is 8. And then the decimal has gone to the left by 4 places. So it's 0.0008. 4 times 10 to the minus 2 is 4, with the decimal having gone 2 places to the left, so it's 0.04. 6 times 10 to the minus 4 is 6, with the decimal going 1, 2, 3, 4 places to the left. And then 0.07 is just 0.07. Okay, so now everything is in the same form. So, what's our smallest number here? It's going to be 0.0006. So our smallest one is 6 times 10 to the minus 4. Our next one is then 0.0008. So it's then 8 times 10 to the minus 4. And then the next guy is 0.04. So that's 4 times 10 to the minus 2. And then we've got 0.07. Okay, number 13 wants us to circle the volume that is the same as 15 centimeters cubed. Now everything here is in millimeters cubed, so what I like to do with these is think of a cuboid here that would have a volume of 15 centimeters cubed. So we could say V is 1 centimeter times 3 centimeters times 5 centimeters. We want the volume in millimeters though, so that's 10 millimeters times 30 millimeters times 50 millimeters. So that is equal to 300 millimeters squared times 50 millimeters. So 300 times 50 is 15,000 millimeters cubed. So this is our guy. Proper job. Okay, question 14. Patterns are made using arcs and straight lines. So pattern A shows us 1 row, pattern B is then made up of 2 rows. So we're then told more rows are added to pattern B so that the number of straight lines to the number of arcs is 10 to 9. We want to work out how many more rows are added onto pattern B. So let's have a look at what's going on first of all. So in pattern A, we've got 8 arcs and we've got 5 straight lines. So I'm going to call those L. Now, in pattern B, we've now got 4 more arcs. So we've now got 12 arcs. And we've got 10 straight lines. So each new row adds 4 arcs and 5 lines. So in pattern B, at the moment, the ratio of lines to arcs is 10 to 12. Okay, so lines to arcs is 10 to 12. So now what we're going to do, underneath this ratio, we're going to add on 1 more row, and then we're going to add on, every time we add on a new row, we add on 4 arcs and 5 lines. and we want to get ourselves to a ratio that will simplify to 10 to 9. So, if we add on one row, we're going to have 15 to 60. So, no. So that's one row. If we add on another, we're going to have 20 to 20. That's 2 rows. If we add on another, we're going to have 25 to 24. So that doesn't. If that's 3 rows. If we add on another one, we're going to have 30 to 28. So that's after 4 rows. That still doesn't simplify. Next is going to be 35 to 32. That still doesn't simplify. That's after 5 rows. One more time though, we'll end up with 40 to 36, which is after 6 rows. And this ratio has a common factor of 4. So divide both sides by that. That is 10 to 9. So it's after 6 more rows. Good times. Okay, then 14b, a different pattern is made using 20 straight lines and 16 arcs. The straight lines and arcs are made from metal. 20 straight lines costs £12. The cost of one straight line to the cost of one arc is 2 to 3. We want to work out the total cost of the pattern. So, first thing we can do here is work out the cost of one straight line. So we know 20 lines cost £12. So one line is £12 divided by 20. Now to do that, we could first of all divide by 10. So £12 divided by 10 is £1.20, and then we do £1.20 divided by 2, which gives us 60p, £0.60. You can break division up like that by dividing by 10 and then dividing by 2. We have divided by 20. So, we now know then that one line costs 60p, or £0.60. So we can now use the ratio to work out the cost of one arc. So we know that line to arc is 2 to 3. Now we know the actual cost of a line is 60p. So, using the ratio on that nugget of information, we're now thinking, well, what would we do to turn it into 60? We would multiply it by 30. So we do exactly the same thing to 3, and that tells us the cost of one arc is 90p. So, the pattern is made up of 20 lines and 16 arcs. So we now need to work out the cost of 16 arcs. So we need to do 16 times 0.9 or 0.90. So to do this, I would round the 90p up to £1 and do 16 times £1, which would give us £16, but we've rounded the cost of one arc up by 10p, and then we've multiplied that by 16. So we've got 16 10p's too many. So we then want to subtract £1.60. So that's going to give us 14.40. So the total price is the £12 for the 20 lines and 14.40, which gives us 26 £26 40p. Number 15. A biased dice is thrown. Here are the probabilities of each score. The dice is thrown 200 times. We want to work out the expected number of times the score will be odd. So what we first of all need to do is work out the probability that the dice will land on an odd number. So for that we add the odd probabilities together. So I'm going to call this probability odd. So 1 is odd, so we got 0.25, and the next one is 3, so 0.15. And then the probability of 5, 0.3. Okay, so 0.25 and 0.15 is 0.4, and then add 0.3, we get 0.7. So to get the number of times we'd expect an odd score, we multiply the probability by the total number of times the dice is thrown. So we now want to do 0.7 times 200. Well, 0.7 times 100 is 70, so multiplying by 200 gives us 140. Number 16. The value of y is 20% more than the value of x. We want to circle the ratio x to y. So a nice way to do this is to pick nice numbers, or a nice number that works well with percentages. So we're going to say that x is equal to 100. 20% of 100 is 20. So y is 20 more than x. So y is 120. So we can say x to y is 100 to 120, which is 10, 212, which is 5, 2, 6. Question 17, we've got a triangle where we know 2 lengths and all 3 angles. We were asked to circle the correct equation. So, everything here is looking like the sine rule. It's important to notice x is a side length, so it's not an angle, so we don't want sine of x anywhere. So we can get rid of this one, we can get rid of this one, which leaves us with these other 2. So the sine rule says that a side, so I'm going to go for x here, over the sine of the opposite angle. So here we got x over sine 42 is equal to any other side divided by that opposite angle. So here we can go 15 over sine 104. I'll put my playlist down below with sine and cosine rule stuff in it. So the guy we want is that chap. Question 18. Everybody loves this question. So we've got a semicircular plastic toy tunnel. The diagram below shows the cross section of the tunnel. So there he is. Now, AD is a semicircular arc of radius 10 centimeters. BC is a semicircular arc radius 7 centimeters. We're told the length of the tunnel is 30 centimeters, and what they want us to do is work out the total surface area of all 6 faces, giving our answer in terms of pi. So, first of all, let's talk about the faces. There is going to be 2 of this shaded face. One at the front, one at the back. That's 2. We're going to have this face, which is like the top of the tunnel, if you like. There's also a face on the inside, which is like the roof of the tunnel, and the other 2 faces we can't see, but they're probably the easiest ones of the lot. They're like the feet of the tunnel. Now, the feet are going to be rectangles. So, let's do the rectangles first of all. So, the rectangles are going to have a length of 30 centimeters, and they have a width of 3. So the area of one rectangle is 3 times 30, which is 90 centimeters squared. So the area of both rectangles is 2 times 90 centimeters squared, which gives us 180 centimeters squared. So there we go, we're off. Okay, the next part that we're going to work out the area of is the shaded arc. So what we need to realise here is the shaded arc is a semicircle with a semicircle cut out of it. So I'm going to call the whole thing the big semicircle. So we're going to work out the area of the big semicircle first of all. So the big semicircle. So remember, the area of a circle is pi times the radius squared. The radius of the big semicircle is 10. So the area of this guy is going to be half times pi times 10 squared. It's half because we've got a semicircle. So we're finding half the area of a circle. So 10 squared is 100. So we got 1/2 times 100 pi, which gives us 50 pi. Cool. Okay, now we're going to find the area of the small semicircle. So the white part, if you like. So the small one is, well, the radius is 7. So it's 1/2 times pi times 7 squared. So 1/2 of 49 pi. So 1/2 of 49 is 24.5 pi. So now we can work out the area of the arc. So the arc, or the area of one arc is, well, it's 50 pi minus 24.5 pi. Now that is 25.5 pi. So that is the area of one arc. Both of the arcs, so the area of both arcs is 2 times 25.5 pi, which gives us 51 pi centimetres squared. So up to here we got both the rectangles and both the arcs. So now we're going to find the area of the top face. Now this top face is basically a rectangle just wrapped around a circular thing. So we know, again with this rectangle, it's going to have a length of 30 centimetres, so that's the length of the tunnel. Now the dimension that we need to find of this rectangle is this arc from A to D. So if you like, half the circumference of what would be this big circle if it wasn't cut in half. So arc AD, well, first of all, let's remember circumference of a circle is pi times diameter. So this arc AD is going to be 1/2 of, well, the diameter would be 20. So it's going to be 1/2 of 20 pi, which is 10 pi. So again, what we found there is this blue length going around the outside of the tunnel. So if this is 10 pi, the area of this rectangle then is 10 pi times 30, which is 300 pi. So we got another area there to add to our collection. So I'm going to call this the top face, and that is 300 pi centimeters squared. Okay, now we need to do pretty much exactly the same thing, but for the inside face this time. So this time we need to find the length of this arc. So again, it's going to be a rectangle, this inside face. And again, one of the dimensions is going to be 30 centimeters. Now, again, this arc is half the circumference of this circle. This time the circle would have a diameter of 14. So arc CD is, well, it's going to be 1/2 of 14 pi. The diameter would be 14. So that's going to give us 7 pi. So now we've got a rectangle with dimensions 7 pi centimeters and 30 centimeters. The area then of this bad boy is 210 pi centimeters squared. So now we have of separate areas. So I'm going to call it the inside face. And he is 210 pi centimeters squared. So the total surface area is these three things added together. So total is, now be careful here, the area of the rectangles 180 centimeters squared is nothing to do with pi. So that is going to remain separate. So we're going to have 180 centimeters squared, and if we add the other three terms, 51 pi, add 300 pi, it's 351 pi, and then add 210 pi, we finally got 561 pi centimeters squared. So our final answer, we could write it as 180 add 561 pi centimeters squared, like that. Good times. Question 19 says type A batteries and type B batteries were tested. This cumulative frequency diagram shows information about type A batteries. So ignore the red and blue lines for a second. Part A asks us to estimate the interquartile range of type A. So the interquartile range, which we're going to call IQR, is the upper quartile minus the lower quartile. Now the lower quartile is the 25% piece of data, and the upper quartile is the 75% piece of data. So we need to find 25% of 80, and that gives us 20. So what we then do on the diagram, we find 20 on the y-axis and go across until we hit our graph, and then we go down to the x-axis, and that gives us the value for our lower quartile. So our lower quartile is 1100. Okay, and the upper quartile is 75% of 80, which is 60. So we do exactly the same thing. We go across from 60 till we hit the graph, go down to the x-axis, and that gives us our value for the upper quartile, which is 1400. So the upper quartile is 1400. So the interquartile range is 1400 minus 1100, which gives us 300. And part B wants us to estimate the number of type A batteries that had a battery life of more than 1600 hours. So this time we start on the x-axis at 1600, go up until we hit the curve, and the batteries with more than 1600 hours battery life are these chaps here. So we go across to the y-axis. Now we see that we hit it at 76. So we then do 80 minus 76, which gives us 4. So that is our answer. Okay, then part C gives us a box plot showing information about the battery life of type B batteries. We are asked, on average, which type of battery had the greatest battery life. So really for this then, the data we want to compare would be the median for each type of battery. The median is the middle value, so let's see what we've got. So type B, the median on a box plot is given by the vertical line inside the box. So the median of type B is 1300. So we now need to get the median for type A. So the median is the middle value. So we find half of 80, which is 40. From the y-axis then, we go across from 40 till we hit the graph, and then we go down to the x-axis. So we get a value of 1260. So type A median is 1260. So type B has a higher median. So we're going to say that type B has the greatest battery life on average because it has a higher median. Jobs are good. Question 20 says a linear sequence starts a plus 2b, a plus 6b, a plus 10b. So a linear sequence means to get from term to term we are adding the same amount. Now we are told the second term has a value of 8 and the fifth term has a value 44. We want to find the values of A and B. So the first thing we're going to do is find the fifth term. So to get from term to term, we are adding 4b. So to get the fourth term, we're going to add 4b to A plus 10b. So that's going to give us A plus 14b. And then the fifth term is going to be A plus 18b. Okay, so we know the value of the second term is 8. So that tells us then that A plus 6b is equal to 8. And the value of the fifth term is 44. So that tells us then A plus 18b is equal to 44. So all of a sudden what we have is a simultaneous equations question. So think of this top guy, equation 1, and equation 2. Both equations already have the same amount of A in them. So we are going to do equation 2 minus equation 1. So A take away A cancels out, gives us 0. Then we're doing 18b minus 6b. So that's going to give us 12b. And then on the right, 44 minus 8 is 36. So if we then divide by 12, we get b is equal to 3. Now to get A, we substitute that value back into one of the equations. So I'm going to sub B equals 3 into equation 1. So that's going to give me A add 6 times 3. So A add 18 is equal to 8. Take away the 18, we get A is equal to minus 10. So our values are A is minus 10 and B is equal to 3. I'll put my simultaneous equations playlist down below in the description. Question 21 wants us to enlarge triangle ABC with a scale factor of minus 2 with a centre of 4, 1. So, there's our triangle and there is our centre. Now, a negative scale factor moves a point to the other side of the centre of enlargement. So, we're enlarging with a scale factor of minus 2. So, each point is going to be twice as far from the centre of enlargement and on the other side of it. So I'm going to go for point A first of all. Now point A, if we count how many places we have to move to get to the centre of enlargement, we go 1, 2, 3, 4 places to the left. So that point is going to be 8 places to the left of the centre. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So point A is enlarged to that point there. If we then go for point B, well, point B, to get from there to the centre of enlargement, we go 2 places left and then 2 places up. So from the centre of enlargement, we're now going to go 4 places left and then 4 places up. So we're going to go 1, 2, 3, 4, and then 1, 2, 3, 4 places up. So that's then going to be there. And then for point C, to get from C to the centre of enlargement, we go 3 places left and 2 places up. So from the centre, we're going to go 6 places left and 4 places up. So we're going to go 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4 places up. So that's where that point's going to be. Then draw the triangle in. If this was the real thing, use a ruler. Okay, for 22 then we have a Venn diagram with a shaded region, and we're asked which set notation represents the shaded region. So you see these little dashes on some of the set notations. So for example, B dash, this second one, that means not B. So if we look at what we've got, well, the whole of the A circle is shaded, and then the whole of the outside of the circles is also shaded. So let's work through these and eliminate what we can. So this first guy means A intersection not B, or A and not B. So could it be that? Well, the answer to that is no. The middle bit where the circles intersect is shaded. So that part contains some of B. So it's not A and not B. So could it be just not B? Again, no, because the intersection is shaded. So it contains some of B. So it's not B. Could it be A or not B? Well, the whole of the A circle is shaded. So that's definitely a good start. And then the whole of the outside is also shaded. Now the outside is not A and not B. So, given that the whole of this circle is A, then we do have A shaded. So if we're inside that circle, that's cool, that's A. If we're on the outside though, that's not A and not B. So this does work. We could either be A or not B at all. So it is in fact A or not B. Okay, question 23 is another question my minions really did not enjoy, so I'll do my best to try and clear it up. So, a shopkeeper compares the income from sales of a laptop in March and April. We were asked by what fraction does the income from these sales decrease in April. So the table tells us comparisons in April to what happened in March. So in April, the price of the laptop was increased by 1/5, and the number sold decreased by 1/4. So in March, what can we say about the price of a laptop? In April, the price of a laptop increased by 1/5 from the price in March. So in March, we're going to say the cost of a laptop was 5/5 the cost of a laptop. Whatever it was 100% of that price. Now, in April, this has increased by 1/5. So, it's gone up to 6/5. So, in April, he is selling laptops at 6/5 of the price he was selling them in March. Now, in April, we sold 1/4 less than we sold in March. So, we're going to express the amount that we sold in March as 4/4. Again, 100% of the amount that we sold in March. So 4/4 is 100%. So then in April, that decreased by 1/4. So that means in April, we sold 3/4 of the amount. So to work out the income in April, we do the fractional cost of a laptop, so we do 6/5 times the fraction sold, so times 3/4. Now that's going to give us 18 on top and 20 on the bottom, which simplifies to 9/10. So the April income is 9/10 of the March income. So the decrease is 1/10. So there was a 1/10 decrease. It's a tricky one to wrap your head around, but I hope that helped. 24a wants us to work out the value of 2 to the 14 divided by 2 to the 9 squared. And we want to give our answer as a fraction in its simplest form. Okay, so bit maths. First thing we need to take care of is the bracket. So when you have powers separated by a bracket, they multiply together. So this is going to be 2 to the 14 divided by 2 to the 18. Now, when you are dividing with indices, you subtract the second one from the first one. So this is 2 to the power 14 minus 18, which is 2 to the minus 4. Now a negative indice puts the number and the rest of the power onto the bottom of a fraction. So this is 1 over 2 to the power 4. So the last thing we need to do here is work out what 2 to the power 4 is. So it's 2 times 2 times 2 times 2. So we get 1/16. 24b wants us to work out the value of 25 to the 3/2. So 25 to the 3/2. Well, to do that, we're going to split the power up using brackets. We're going to say this is 25 to the 1/2 cubed. 25 to the 1/2 means the square root of 25, which is 5. So this is 5 cubed, which is 125. I'll put my indices playlist down below in the description. There's plenty of examples of all kinds of questions. Question 25. So we've got a sketch of y equals cos of x for x between 0 and 360 degrees. It's one that we should be familiar with. Now for part A we are told that cos of x is equal to cos of 60. We want to work out the value of x when x is between 90 and 360 degrees. So the first thing this question relies on is your knowledge of the exact trig values. So, well, here we want cos of 60. We really should be able to work out sine, cos and tan of 30, 45 and 60 degrees. If you're not sure on how to do that, I'll put a link to my video down below in the description. For now, I'm going to tell you that cos of 60 is equal to 1/2. So what this is asking us to do is, well, first of all, if we put our value of 1/2 here, if we go across from that till we hit the graph, then we go down, our 60 degrees is roughly there. So that's what cos of 60 looks like. What it means when it says find the value of x, when the x is between 90 and 360, is that, well, this line y equals 1/2 goes on forever. So what we're after is the value of x that gives us this second solution over here. Now, the cos graph is symmetrical, so this first solution is 60 degrees in from 0, so this solution over here is going to be 60 degrees backwards from 360. So our x value here is 300. And that is the answer, 300 degrees. Part B says cos of x is equal to minus cos of 60. So, minus cos of 60, this time is going to be minus 1/2. We want to work out the value of x when x is between 180 and 360. So this time, we're going to draw a line going across from minus 1/2. Now we want the value between 180 and 360. So the guy that we want is the x value here. Now, again, we can use the symmetry of the graphs. The distance between 180 and this solution is going to be the same as the distance from 0 to 60 or from 360 to 300. So 180 add 60 is going to give us 240. So that's our value of x for part B. Quite tricky, probably. 26, we got some ratio fun. So B is 2/3 of C. 5A is equal to 4C. We want to work out the ratio A to B to C. Giving our answer in its simplest form where A, B and C are integers. So, basically we're given two equations. We're going to want to turn each equation into a ratio and then combine those ratios. So, let's start with B is 2/3 of C. So, as an equation, we can say B is 2C over 3. If we multiply by 3, we get 3B is equal to 2C. So now we want to turn this equation into a ratio. So here's a really nice trick for doing this. Underneath the equation, we're going to write the ratio, but the letters swap sides. So we're going to get C to B, like that. Now the coefficient of B is the C part of the ratio. So we get 3, 2, and then the coefficient of C is the B part of the ratio. So C to B is 3 to 2. Or we could say B to C is 2 to 3. Okay, so now we're going to do the same thing with 5A is equal to 4C. So 5A is equal to 4C. Underneath the ratio, underneath the equation, we're going to say C to A is 5 to 4, or A to C is 4 to 5. So now we have both of our ratios. Let's put B to C up here. Okay, so there are both of our ratios. We now need to combine them. So the trick to doing this, or the key to doing this, is the letter that pops up in both ratios. So here, that's C. Now you can multiply ratios by any number that you want, as long as you multiply both sides by the same thing. So we're going to multiply each ratio separately, so that the C part is the same. So the first number, that 5 and 3, both go into is 15. So to turn 5 into 15, we're going to multiply by 3. So A to C, we can say is 12 to 15. And then for B to C, well, to turn 3 into 15, we multiply by 5. So we're going to get 10 to 15. So now that the C parts are the same, we can say that A to B to C is 12 to 10 to 15. And I suppose we might as well write that here. I'll put a link to my combining ratios videos down below in the description. 27. Joe wants to work out the solutions of x squared plus 3x minus 5 equals 0. She basically says it can't be done because it can't be factorised. Is she correct? Well, the answer is no. Not all quadratics can be factorised, but they can still have solutions, and to find them, we could use the quadratic formula. Okay, then part B says, without expanding any brackets, show how to work out the exact solutions of 9 lots of x plus 3 squared is equal to 4. Okay, so we're not allowed to expand the brackets, which is good. First thing we can do is divide through by the 9. So that gives us x plus 3 squared is 4 over 9. We can then square root both sides. So we're going to get x plus 3 is equal to plus or minus, that's important. When you square root, you do get positive and negative. So the square root of this fraction is the square root of the top over the square root of the bottom. So that's going to give us 2 over 3, and then we're going to subtract the 3. So x is minus 3 plus or minus 2 thirds. So x can be minus 3 minus 2 thirds, which would give us minus, well, if we think of 3 in terms of thirds, every whole one is 3 thirds. So this is minus 9 thirds, minus 2 thirds, which is minus 11 thirds, or x can be minus 3 plus 2 thirds, which is minus 9 thirds, add 2 thirds, which gives us minus 7 thirds. 28 wants us to simplify root 80 and root 2 and 2 ninths, giving our answer in the form a root 5 over b. So, I'm definitely going to put a link to my Surds playlist down below. Basically, we want to do this step by step and split it up. So, we're first of all going to simplify root 80. Now, can we think of a square number that goes into 80? I'm not going to take the direct route. Let's say we swap 4 goes in. So we could write root 80 as root 4 root 20. Now this is 2 root 20. Now root 20 still has a square number in it. So 2 root 20 we can write as 2 root 4 root 5. Now this means 2 times root 4 times root 5. Root 4 is 2. So this is 2 times 2 root 5. So it's 4 root 5. The direct root there was that 16 goes into 80 5 times. So root 16 root 5 is 4 root 5. So we know root 80 is 4 root 5. Now we want to play around with root 2 and 2 halves. So the secret to surds with mixed numbers is that you don't want surds with mixed numbers. So we're going to turn this mixed number into an improper fraction. So to do that, we multiply the bottom of the fraction by the whole number, so 9 times 2, and then add the top of the fraction. So this is going to give us 20 over 9. Now this is root 20 over root 9. Now we've just seen root 20 is root 4 root 5. So we got 2 root 5 over square root of 9 is 3. So root 80 and root 2 and 2 ninths is now 4 root 5. Let's go down here where we've got more room. So we've now got 4 root 5 and 2 root 5 over 3. So this is where everyone seems to struggle with this question. Let's just say that we're doing 4 add 2 thirds. So forget the root 5s for a second. 4 as a fraction in terms of thirds is 12 thirds. So we got 12 thirds and 2 thirds. Now that's going to give us 14 thirds. So 4 root 5 add 2 thirds root 5 is 14 root 5 over 3, or 14 thirds root 5. 29, we got two graphs. We got graph A and the graph of y equals x squared minus 1. Now we are told the graph of y equals x squared minus 1 is translated 3 units to the left to give graph A. The equation of graph A can be written in the form y equals x squared and px and c. We want to find the values of b and c. So this comes down to graph transformations, which is pretty tricky stuff. I do have videos on it. Links will be down below in the description. So y equals x squared minus 1 is translated three places left. So the vector for that is minus 3, 0. Now, if we say that f of x is x squared minus 1, then graph A is f of x plus 3. That gives us our translation 3 places to the left. So, remember, f of x is x squared minus 1. F of x plus 3 is, well, the x becomes x plus 3. So it's x plus 3 squared minus 1. Now if we expand those brackets, x plus 3 squared means x plus 3 times x plus 3. So we will get x squared add 6x add 9 minus 1. So we get x squared add 6x add 8. So B is 6, C is 8. Definitely tricky stuff for GCSE level. 29b says the graph y equals x squared minus 1 is reflected in the x-axis to give graph B. We want to work out the equation of graph B. So, a reflection of f of x in the x-axis is given by minus f of x. So graph B is going to be minus x squared minus 1, or the negative of it. So graph B is minus x squared minus 1. So is minus x squared plus 1. Cool. Alright, question 30. The grand finale. We want to show that the value of cos of 30 times tan of 60 and sine of 30 is an integer. So a whole number. Now again, we're relying here on our exact trig values. So I'm not going to go through how to work them out here. There is a link down below. So cos of 30 is root 3 over 2. Tan of 60 is root 3. And sine of 30 is 1/2. So our expression is then root 3 over 2 times root 3 add 1/2. So root 3 over 2 times root 3 is root 3 times root 3 over 2. So that's 3 over 2 add 1 over 2. That's going to give us 4 over 2, which gives us 2, which is an integer. There we go. Job done. Paper finished. If this has helped, guys, don't forget to give us a thumbs up, get subscribed, share with your friends. Always a good time. Hope to see you in the other papers.